Hey, how's everyone doing? We got Jackson here, we got Blake here, we got Santi here, we got Lachey here, we got Jackson. Jackson here's twice. What questions are there? I got my second cup of coffee right here. Mubot is now awake. If you've got those questions, put them in the chat. We were doing the My Pearson quiz 6 earlier. Or we could do some 320, you never know. 320's got an assignment coming up. What questions are there? I think we're streaming, right? Let's see. Let me go to live chat. Could you work some chapter 3 reviews? Sure. What are you wondering about chapter 3? Chapter 3 is going to be about some mosaic plots and some good stuff. What are you wondering about with some chapter 3? Chapter 3. What are we wondering about with chapter 3? Let's take a look at some chapter 3. All of it? All of chapter 3? All of chapter 3. Yeah, let's do some recognizing. Okay, let's do that. So, Stat 201, chapter 3 review. And let's do this. For town. Okay, says chapter 3, Stat 201. And let me pull up some data right here and let's take a look. And here we go. Let's check it out. Okay, so chapter 3 covers a lot on mosaic plots. So let's talk about mosaic plots. Also the paragraph I put above that one. Being able to calculate a relative frequency, being able to calculate a marginal distribution, being able to calculate a conditional, interpret segmented bar charts, mosaic plots. Yeah, let's do that. So we have right here study habit. And then we have right here grade. And let's go A, B, C, or lower. A, B, C, or lower. And let's do one more. So now we have class goes to class. Let's change it. Yep. And then let's go right here and put stays up all night. This is Brian. That is my literal study habit when I was in college, was stay up all night. I wish I could talk to myself and say, don't do that. Let's say goes to class / stays up all night. Okay, so this is the combo people. We'd say both. So we'll say both right there. So now what we're going to look at is we're going to look at the frequency of these observations. So here we're going to go to frequency. You don't need to know how to make this, but we're talking about what this means. So we have goes to class and makes an A, let's say 120. Both, this right here. Oh, I didn't permutate it right. Goes to class. Both. Stays up all night. There we go. So goes to class, makes an A. And there we go. Both, we'll say 80, 90, 10. Stays up all night. Right here, 10, 20, 50. Okay. Is there a Quizlet? There might be. I have had Quizlets. People are saying Quizlet charges now. A mosaic plot is the relationship between what variables. A mosaic plot, and you can see the colors here, is a relationship between what two types of variables. A variable that is what and a variable that is what. A mosaic plot. A mosaic plot is the relationship between two variables where both variables are what. A mosaic plot. A mosaic plot. The Kahoot broadcast last night. Check it out on the list. 2 categorical variables. Santi, if you can't find it, let me know. We'll find her after this. If you can't find it, it'll be in the most recent broadcast videos right there for the Kahoot. Good stuff right there. So good stuff. We're gonna see if your grade, which is the Y variable of interest, can be explained by study habit. Does that make sense when I say, is your grade, which is the Y variable, why do you get a certain grade? Is it explained by study habit? So is grade, the one we are interested in, the Y, explained by study habit? See, it's kind of like the questions we were doing earlier. A little bit interesting stuff right here. So if you take a look at this, why is stays up all night smaller along the bottom? What does it mean that stays up all night is smaller along here? What does that mean? What does it mean that stayed up? There are less people doing that, right? There are less people who stayed up all night. A lot of people go to class or do both. Like a lot of people. I seriously, I went to class most of the time, but I was I was really bad. Like night before the exam, I'm going to stay up all night. No, that just really throws your schedule off. It's better to get out of the habit of doing that. I'm speaking to past Brian. So the more you can go to class, the more you can like keep yourself to a regular schedule, the better your body just kind of works. I'm talking to myself even now. So try to do that right there. I would say it's 40. It might be. Let's find out the exact. I think it's more like 40, 40, 20. Maybe 38, 42, 20, something like that. And to do this, we need to calculate the what. To do this, we need to calculate the percentages in the whats. To do this, we need to calculate the percentages in the whats. You might have been almost, you're very close. To do this, you need to calculate the percentages in the wheres. Kind of the columns, but we call it in the table the percentages in the whats. So think about how would you calculate what percent stays up all night using the numbers down here. How would you calculate what's the probability a student stays up all night, which is how a test question could look. Literally doesn't. There we go. A test question could say, what is the probability a student stays up all night? So what is the math using the table below to figure out what is the probability a student stays up all night? Who can calculate that using the numbers right here? What is the probability a student stays up all night? So this is like I'm writing test questions now as I ask this. So try, if you're watching this in the future, try pausing the video. Given that, so we could try, so we wouldn't say given that, is an A student. We could do that next here, Blake. So we'll do that next. Good question, Blake. But what's the probability a student stays up all night? So just the question is, and I'll write it on the screen so people can see, try solving these questions along with us. The only question that we're asking right now is, what is the probability a student stays up all night? So the question is, what is the probability a student stays up all night? It might be 18%. That sounds about right. Let's check the math. The math for it is going to be, I'm going to disappear on the screen. So we're talking about all students. We're talking about 80 out of the 440. And there it is right there. 18.18%. Great job, Lachey and Jackson right there. So we call this a what distribution. We're only looking over here. This is the what distribution. What is the probability that a student stays up all night? That is a what distribution right there. Hint, it's over here in the margin. And then we'll do Blake's question right here next. It's in the margin. So that is called a what distribution. This number and this percent, like what is the probability a student stays up all night, is only asking about one variable, marginal. Great job, Jackson. And Blake wrote, what is the probability? I think we can do the formatting. There we go. Given that a person is an A student, what is the probability the student stays up all night? So given that they are an A student, what is the probability to stay up all night? See if you can solve this one. I'll show you the math here in a second. But solve this question that Blake wrote. Great job, Blake. This is, if you can make up these questions and then solve them yourself, you understand how to do it. So given somebody is an A student, we'll make this really nice and near here. We're going to do a bunch of questions practicing this. Given somebody is an A student, what's the probability they stay up all night? So how would we find this? How would we find this? Given somebody is an A student, given that a person is an A student, let me see. I think Jackson has it. I think so. Exactly, right? Right, Charlie? All this stuff carries over from 201. Great job, Santi, right there. All this stuff we do in the lower level classes carries over. Good to see you, Evan, right here. And Charlie, we got to throw 1,000 points for a random Charlie appearing. So all this stuff you're doing in Intro to Statistics carries over. So we'd look right here and we'd grab, maybe I need to take a screenshot of it. Probably the best thing to do is to draw on it and say, given somebody is an A student, we're only talking about these students right here. So then what's the probability they stay up all night? It's 210 out of 10 out of 210. Great job right there, Jackson. And that's how we would get it. And this is called, great job, Lachey right there. We got to throw another 1,000 points. Great job, Lachey, practicing. Everyone, keep up the practice and remember how to solve these problems. So what is, given someone stays up all night, what is the probability they are an A student? Given somebody stays up all night, what is the probability they are an A student? I go to band class. Band class sounds cool. I was in piano class in high school. Love some piano. Pianissimo. Given someone stays up all night, what is the probability they are an A student? So how would we find this one? Given someone stays up all night. Given someone stays all night, what's the probability they're an A student? Let's see what people say. No one solved it yet. So this right here is going to be, well, the relative frequency is a percent. So we're finding the relative frequency. It sounds like, yep, I think 10 exactly. So people are finding the answer right there. We'll draw on it again. So this one actually goes the other way. This one is given someone stays up all night, what's the probability they're an A student? So it's going to be 10 out of 80, 12.5% right there. So that's the probability right there, 10 out of 80. Oops, we lost that. So 10 out of 80, which is 12.5%, which is a relative frequency. Relative means relative to a percent. So just good practice. We're just trying to nail these down, to hammer them down here. If a student were to be a B student, what is the probability they go to class? Go to class, or go, what is the probability they are in the group goes to class? So just one more right here, finding the, and great job, Evan, right there. One more finding this right here. If a student were to be a B student, which I didn't use the word given, you don't always have to say given. I like to say given. You might be able to rephrase things, but I didn't say given. I said if a student were to be a B student, what is the probability they are in the group goes to class? So what would this be right here? I'm kind of solving it too. I think I can about get it. Trying to solve it in my head. Should be 26.66666. Is it 26.6666? I think so. Tell me if I'm wrong. I think it is. Solve the math. And Evan's got the numbers right there in the chat. I think it's 26.66, right? 26.7. Yep, round it up. So we go right here and go 40 divided by 150, and there it is right there. So try solving these out. Try practicing. Try writing your own problems. The more of your own problems you can write, the better off you are. The more of your own problems you can write to understand how these work. And then when you think about this, we want to know if there's a relationship in the data. Now, if there is a relationship, the conditional distributions differ. You can see right here the people most likely to get an A are the people who go to class, where we just calculated. Remember, if someone is a B student, we calculated a different probability. But what is the probability of people staying up all night making a B? Well, that's C or lower, rather. It looks like it's B, but that's actually the C or lower over there. So the probability of somebody making a C or lower if they stay up all night, show the math on that. So stays up all night, 50 out of 80. And you can see right here 62.5. And I thought I was going to show it, but watch this. There it is, 62.5%. Does that make sense that you're seeing the conditional distribution right there? And this is called the conditional because it's for only people who stay up all night. This is the conditional distribution right here. Are there any questions on this? To see if there is a relationship, we look for differences in the conditional distribution to where if we saw something, let me have it auto recreate. In this instance, we would say there's really not evidence of a relationship. So here's how it would look when there's not evidence of a relationship. Watch this, 50, 50, 120. And it doesn't have to be the same ratio or same amounts. It could be something like this. Now, why here? I did that exactly. Why, when you look at this, does it look like there's not evidence of a relationship anymore? Why does it look like here there's really not evidence of a relationship? And it doesn't have to be exact. We can make it a little bit off. Why does it look like to you here there's not evidence of a relationship? Why does it look like? Good seeing you, Charlie. Excellent work. Why does it look like there's not much evidence of a relationship? Because all the conditional distributions look a lot like the what? These are the conditionals right here. This is a conditional. This is a conditional. This is a conditional. All the conditionals look a lot like the what's over here on the sides. All the conditionals look like, they look the same and they look a lot like the marginal. You see how I'm highlighting the marginal, which is for all the data? So the marginal distribution looks a lot like the conditional. So you would say here there really aren't any differences, where in the previous example, you can see big differences where there looks like a difference between the groups, to where over here we can see there doesn't look to be much of a relationship between the groups. So this would be where there's really no evidence of an association, and this would be where there's this would be where there's evidence. You know what's interesting? This is a what relationship. To hit one last topic right here, this is a what relationships. Look at the p-value. This is a review question from earlier. This is a what relationship. The bigger the gaps, the stronger the relationship. So you see how there's really big gaps. At what point are the gaps big? Well, the bigger they are, the stronger the relationship. So if the gap is like this, that's a big gap. So don't worry about finding it exactly. This is actually one of the last chapters we do, because we'll circle back to it and we'll talk about statistically significant. Think about this real quick. The relationships here are most likely, or the differences here are most likely by what? The bigger the gap, the stronger the relationship. The bigger the gap, the stronger the relationship, the more the variables are related. Differences here are probably just by what? Think about the p-value being high. The differences between the groups are probably not outliers. Good guess, Jackson, right there. And Santi and Jackson, good work and good guesses. Remember, if you were here for p-values earlier, the differences here between the groups are likely differences by what? The differences here that we see between the groups are likely differences by what? The differences between the groups are likely differences by what? The differences between the groups are likely differences by random chance. Do you see how this is like very small differences? So we'd say the differences between the groups are just likely by random chance. Where if you look at the other example right here, these are large differences that are unlikely by random chance. Does that make sense? Like there's large differences between these groups that look unlikely by random chance, where the differences here are very small and likely by random chance. So the p-value right there gives us the probability that these differences are by random chance. And so this would say these differences are not likely by random chance. We think something real is going on right here, where the p-value here says these differences are likely by random chance. Like it's just, there's no real relationship between them. Everything you're seeing here is likely by random chance. That's a more in-depth topic, especially when we get into the chi-squared test of independence. What other things should we do? Should we do more chapter 6 quiz? Your guys' office hours will head back to the main screen. Go to review of the topics. What should we do? Jackson, Santi, let me know your questions. Drop them here in the chat. What should we cover? My fantasy football team won last night. Use common scaling on histogram when making comparisons. So when you compare histograms... Yeah, Santi, excellent work. Thank you for being here, Santi. When you make histograms... Same, awesome. Let's talk about chapter 4. That's chapter 4. Chapter 4 review. Chapter 4 review. Tell people hashtags show up. Let me go look at some chapter 4 stuff. Chapter 4 review. And then we'll start some chapter 4 review. Okay. Let's go do it. Chapter 4 review. Here we go. So chapter 4 is about comparing multiple distributions. Everyone's here for some review. What are some ways to compare two quantitative distributions? What are some ways to compare two quantitative distributions? Hence, I'm not blocking any right answers. Well, kind of. What are some ways to compare two quantitative distributions? What are some ways to compare two quantitative distributions? So use the graphic on the screen right here to remember. Well, that'll be two quantitative variables. So if you have height and weight, we can make a scatter plot. But let's say, so Blake, let me ask it again. Let's say you have two groups, hint, two groups, where you have students in class A and students in class B, and you want to compare the grades. So if you wanted to compare, So compare the grades of students in class A to B. How would you do that? Box plots, yep. So if you wanted to compare the grades of students in class A to students in class B, class A, class B is a what variable? And this is why it's groups right here. So two quantitative groups, or a quantitative variable between two groups. Class A, class B is a what variable? It's categorical. And then right here, you have a quantitative variable, which is grades. So grade over here, got grade as a quantitative, and then class A, class B. And the combo you get from this, the combo you get is side-by-side box plots. Now, what's interesting is the differences between these box plots right now looks to be what? You know, we could assign p-values to this, just show how these topics that we're doing, these advanced topics, are the same thing. It looks like, is there a difference between these class A and class B right now, or the differences look to be what right here? What does it look like? They look similar, right? So the p-value would actually be kind of high because any differences we see are what? They're not statistically significant. Any differences we see between these right now, this is an advanced topic for those who've been hearing all the p-value talk lately. The differences we see between them are probably just due to what? The differences we see between the box plots are probably just due to random chance. Does that make sense? But how about this? If it goes down here, now the p-value would be lower because the differences you see are unlikely due to random chance, and there's a statistically significant difference. Does that make sense? Like, hopefully drawing these concepts together of p-values to say now it is statistically significant, i.e. below 0.05, and the differences between these look unlikely due to random chance. So we're not really here to review p-values as deep as we've been doing this, but it helps with understanding, especially later chapters. So with this, we have side-by-side box plots, but side-by-side box plots is not the only way to compare multiple distributions. Another way to compare multiple distributions is with what? And I'll draw them out for you right here. Another way to compare multiple distributions is with what? Stacked histograms, yep. So you got to be careful, though, because when you do stacked histograms, what do you want on your stacked histograms? What do you want on your stacked histograms? What do you want on your stacked histograms? On your stacked histograms, you want what's? So you got your quantitative variable right here. You want context, and how do you give it good context? How do you give it good context? How would your stacked histogram? You got class A, class B, and how do you give it good context? They should have the same what? How do your histograms have good context? Vertical scale, important, but more importantly, the horizontal. Vertical scale, I do agree with, but I mean, so yes, you do want same vertical scale. Like, that's not a trick question. Same vertical, same horizontal, same scales. Does that make sense? Like, same both scales. Like, vertical is, yes, we do want that, but if it's not horizontal scale, that's a major problem. So you want the same scales on them. Does that make sense? I think you were asking about something like that earlier. If you're comparing two distributions, you want the same scales. And when you think about box plots are ideal for comparing multiple distributions. When you think about how can you compare things, like a box plot is not ideal, but box plots multiple are ideal for comparing multiple distributions. But I want you to look at it. Let's say that we have the same data right here being displayed, where it's group A, group B. Technically, B was lower. So let's draw this out. I want you to tell me what you can see from the data in the histogram that you couldn't see in the box plot. Okay, so this is the same data. So you've got the box plots up top, and then you've got the data down below. What do you notice about the data that's in the histograms that you don't see in the box plots? And sometimes people will draw the box plots below it or above it, like Jump does. So here's your box plots again. There's the box plot for B. Here's the box plot for A. What do you notice that you can see in the data, in the histograms, what do the histograms let you see? Histograms are better for showing what of data? Histograms are better for showing what of data? The histogram is going to be better at showing what? Well, not right skew, not right skew. Good answer, Santi, right there. Remember, little monster man. Got to throw some points out. The shape. There's our monster man right there. So monster man, right over there. Great answer, Santi, right there. Uniform versus skewed. This one's uniform right here. It's one form. This one's skewed to the left right there, left to the low, right to the high, whatever way the monster man's tail goes. So this data could technically look like this. It might be uniform. And so this is distribution A right here. This is distribution B. And it's easier to tell the shape from a histogram. Histograms are not going to hide features like box plots do. Also, box plots show that exactly. So box plots show the 5-number summary. They show the positions in the data, the 0, 25th, 50th, 75th, and 100th percentile, also showing us things like the IQR. So it's important to know what the box plot's going to show you. It's good for showing a summary of the data like the 5-number summary, showing outliers that are 1.5 IQRs above Q3 or 1.5 IQRs below Q1. And so the box plots are going to show you that information, where histograms are going to be your better ideal understanding of shape, and they should have same horizontal axes right there. Good review. I'm trying to think what else to say. But then we have right here, let's go over here, and somebody made a 280 on the test. What are your thoughts on this? Like if I'm looking at my grade book and I see a 280 or even a 180, what is Brian going to think when he sees a 180 in his grade book? Outlier, right? In the box plot, it would look like a dot. That's in distribution B, right? And then in the histogram, it would be a bin. It'd be a little bin. That's the way it would look in the histogram. It'd be a little bin over there. In the box plot, it'd be a dot. So could we remove that dot? Or we could do it as a dot plot or a stem and leaf. Should we remove this dot when we do the analysis and do calculations? What are your thoughts? What are your thoughts? Should we remove that, yes or no? Hey, Muskin, good to see you here. Drop any questions you have in the chat. Should we remove that outlier? Should we remove it? They have a 180 on the test. And not because it would change the data. And yes, you should remove it probably. There is sometimes a good reason to remove outliers. You can remove them, especially when they're data misentries. What do you think the person probably meant to enter in? If it says 180, what do you think they probably meant to enter in? You should go and look at the data. You might be able to correct it. You might remove it from analysis. What do you think they probably meant to enter in if it was entered in as 180? Like they probably meant this. We don't know for certain. Maybe 80, maybe 100. But there's a lot of grades around 80. So my guess is a button was misclicked. Maybe it was 81. You don't know. Maybe they want to give them a 180. You don't know. So we got to be careful. There's sometimes a good reason to remove outliers. We want to check with the original data. So maybe, but there is sometimes a good reason to remove outliers. Like, especially when you get data that just doesn't make sense. Like if the teacher told you your grade on the test was -80, you'd be like, how do I get a -80? That's not possible. Let's over here, more review. What should we do? It's your call. It's your review. What should we do? Drop those questions in the chat. Whatever you want to review, we'll do it. What questions do you have? Quiz, Canvas content, you name it, we'll do it. We've just been rocking and rolling, going through chapters, talking about some concepts. What should we review? People say. I can't remember if we went over frequency table versus relative frequency table. Sure, let's talk about frequency versus relative frequency tables. And Stat 201, frequency versus relative frequency. Let's check it out. Here we go. Oh my gosh. Click a wrong button right there. Cover standard deviations, z-scores, and how to find percentiles. Yeah, let's do that here soon. You got it, Santi. So everyone in the chat, love it. Okay. So a frequency table displays what kind of data? Put the hints on the screen. A frequency table displays what kind of data? A frequency table, you're welcome, Santi. A frequency table displays what kind of data? A frequency table displays what kind of data? Categorical. So a frequency table just shows you the frequency of observations in a group. Like, always try to memorize it that way. So we would say right here, here are the grades on the first test. And we go right here, insert table. And we say A, B, C, D, or lower. And 100, 70, 20, 10. Okay. So is this data quantitative or categorical? Categorical or quantitative? We'll put a C or Q for a vote. Is this data quantitative or categorical? Is this quantitative or categorical? Is the data on the screen quantitative or categorical? See what people say. Caught some people. Don't worry, don't worry. What is this graphic called? What is this graphic called right now? What is the name of this graphic? What is the name of that graphic on the screen currently? The name of that graphic is called a what? What is the graphic called on the screen? Like, that is a what? That is a what right there? That graphic's a what? Frequency table. So it's categorical. Does that make sense? That is a frequency table. It is definitely categorical. Don't worry if you got it wrong. Don't worry if you got it wrong. You got to throw some points. That is a frequency table. It's definitely categorical. So now that we have, you see, we're almost 50-50. So remember, even though you're seeing numbers, answer the question for me. What grade did you make on the test? We'll throw some more points up. Like, if you answer the question for me, what grade did you make on the test? Someone might say I made an A, and then we would count the frequency of observations. Does that make sense why it's called a frequency table? If someone says I made an A, there were 100 people who answered I made an A. So I had a student come up to me and said, no, these are numbers. I can subtract them, like 30 more people. And I said, but the question, so always look to the question, which was, what was your grade on the test? So we're summarizing the data. Does that make sense why this is like a summary of the data? So what was your grade on the test is the question, and then we're summarizing it by saying 100 people answered that they made an A. Now that is quantitative, but that's the amount of people who answered that category. So there's different categories. Like if I say, what is your hair color? Is that quantitative or categorical? If I say hair color, is that quantitative or categorical? Nice and easy question. So if I say, what is your hair color? Is that quantitative? It's categorical, right? So now we would have here black, brown, red, blonde. There we go. So, and now we could have the same numbers. Just for example. So this is not quantitative because it's not a quantitative amount of hair color. It's how many people are in each group. I think the test might confuse people, or the test grade, because grade can be considered a quantitative amount, like what was your score? That's quantitative. But now that we have what is your hair color, the question is clearly categorical, and thus we have a frequency table of the frequency of observations. So to turn this into a relative frequency table, a relative frequency table is going to be what? Well, how many observations are there? To make this relative frequency, how many observations are there? To make this relative frequency, we first need to know how many observations there are. I made the numbers nice and neat. Well, there's 4 groups. There's 4 categories. But there were how many people who answered our survey of what is your hair color? How many people total answered our survey of what is your hair color? $200, right? So to do relative, we do 100 divided by 200, and we'd get relative frequencies. I made the numbers nice and neat. Does that make sense how this is now the relative frequency for the groups? Great job, Christian, Muskin, and Lachey right there. Got to throw some more points. So does this make sense here? Now these are relative frequencies. So you can make a frequency table. 100. Here, we'll drop this into jump. And we would just say hair color. There are tons of companies that love if you have the skills to make data, to visualize it. And then we got frequency right here. And let's call it frequency. You don't have to know how to use jump at this level, but it's not bad. Let's go to graph builder and let's put in the frequency down here. There's the frequency. Let's drop hair color right here as the X variable of interest. And there you go. There is a bar chart. There is a pie chart. We could also make frequency table. We don't want to make a box plot. No. You gotta be careful. You can make mistakes like that. We could also add color right here, and there you go. There's the color on it. So there's a bar chart. What am I making if I put the bars in order? If I put the bars in order, what have I made if I put the bars in order? Putting the bars in order would make a what? Putting the bars in order would make a what? Oh, calm down, jump. Putting the bars in order would make a what? Are you sure you don't want to take the exam? Putting the bars in order would make a what? What is this called over here? If you put the bars in order, you have made a what? And you always want to click down on these after you're done with them. Oh, we want to add the numbers. Well, show control panel, label. There you go, done. There we go. Got to make some pretty graphics right here. It's Pareto plot. So the Pareto plot, you don't need the frequency stuff like the cumulative, but we could just show it like this right here. The bars have been put in order. Pareto. Oh, no worries. No, you spelled it right there. Pareto. Great job, Blake, right there. So you can make a bar chart, a pie chart, a Pareto chart, a frequency table. We've got the frequency table back behind here, or a relative frequency table, and that's why we show this right here with all this. You could also make ring charts, which are pie charts with the center cut out. So really good stuff just going over these types of graphics here, Blake. I think the next question we have is about z-scores and percentiles on the curve. So let's go do that. Excellent work. Drop more questions in the chat. Whatever you want to do, we'll do it. Z-scores and percentiles. Stat 201. Z-scores and percentiles. Okay. Let's see this. What are unusual features of a histogram? Outliers, things like that. Definitely outliers. Outliers are unusual features. There's like gaps and outliers for unusual features. Like gaps create outliers. Good question right there, Blake. So outliers. Yep. Oh, nice job, Evan, right there, helping out. Evan, do you have two accounts? Because you might be a mod on your other account. We'll make Evan a mod right here. But good questions, good answers, everybody. Let's think about this. What percentiles can you find without the David M. Lane applet? So, Evan's a hacker. What percentiles can you find without the David M. Lane applet? Let's draw out the curve. And there should be a very easy percentile to find at the start. What is the easiest percentile? Great job, everyone cheering on. Evan, you crazy, man. What is the easiest percentile? Well, those are, or careful, 68, 95, 99.7. We sometimes show that on the test, so use it to help your drawing. Because I do suggest drawing this out at the start of the test. You can't have it drawn out to start. And Santi, you got it right there. Don't worry about the mistype. Santi is correct that the easiest percentile to find is the 50th percentile. That's going to be the easiest one to find right there. Now, we can probably draw out our 68. Let's do it right here. 68. 95, 99.7. Now, how are we going to use these numbers? There's lots of ways to find the answers to these questions. But let's go for the easiest one to get to start. I think the easiest thing to do right here, this is an easy thing to do, like one of the easier ones to get, is to take right here and to cut 68 in half. If I cut 68 in half, how much are these areas worth? This isn't easy, just practicing is something we should know know and practice. Great job. We had someone solve this day in class. But if I cut 68%, then what are those worth right there? If I cut it in half. Like I have one area over here and I have another area over here. I've cut the 68 in half. So how much is one of those worth? Not quite 16. I see what you're doing. You're going and you're finding this. Don't worry, you're finding this right here. But I'm asking, don't worry, everyone did it right there. I'm asking this right here, that shaded area. Great job, Jackson, right there, 34. Now, there's a lot of ways to solve this. It comes down to practice and just trying to solve it and practice it out. Because if you know that that is 34, right? Does everyone see how we got that this is worth 34 right here? Let me show it again. Yeah, I know. I mixed it up this time for practice. Like, you know, like if you're working out, sometimes you like work out differently. I don't even know how to work out, but you're trying to exercise the muscles in a different way to be like, okay, how much is this worth right here? Does everyone see how that's half of 68? Visually, does that make sense? The blue area right there is half of 68 because 68 would be the total within this, but we're just finding half. Does that make sense right there visually? Like that's going to be half of 68. Do people follow along with that? Awesome right there. Got it? Nice work. So now that we know that that's half of 68, well, if that is 34, which we just said it is, then this is also 34. Then what percentile are we at right here? We're just doing an easier one. What percentile are we at on the highlighted point? What percentile are we at? What percentile would that be right there? Not the 75th. Good guess. How would you figure out the percentile right there? The 84th. Why is that the 84th percentile? Why? Good answers right there, everyone. Good practice. Why is that the 84th percentile? Why is that the 84th? Great job, Christian, right there. Why is that? We'll throw 1,000 points. Great job, Santi, right there. Yes. This is where you want to practice writing this down with me. And if you write it down, if you practice it out, it'll give you a better understanding where the percentiles are at. Blake's seeing right there too. So how would you figure out the percentile for here? How would you figure out the percentile for here? So try to figure out the other one. Where would what percentile would that be on the curve? What percentile would that be on the curve? Great job, Christian. You're right. Yep, you're seeing it. Once you do it a few times and you get it down, you can be like, that's the 16th percentile. So now let's figure out the percentile here and here. Now, we already know that this is the middle 95%. So we could use that knowledge of the middle 95% to help us. And remember, the percentiles are going to go in order. Yes, Blake, that is correct. So you could solve it with that trick too, Blake. You can use all different tricks. You could do the half thing again right here. So if you want, well, that's going to be between, so the 13.5 is the area between here and here. Because if you add these up now, you'll get 47.5, which is half of 95. But think about ways to solve this. Well, 2.35 is the area between the next. 2.35 is the area there and the area there. So 2.35 is the area there and there. But what are the percentiles? We're asking specifically, like, what are the numbers right here? What are those numbers? So what are those numbers? Because we're just talking about percentiles right now. How would we solve that? I'll answer the question. I'll show you how to solve it, but take some guesses. Keep working through it. And when you start to connect what these numbers mean, you get better at solving it. And you're like, okay, we need the percentile, which is the area below there. And the answer is going to be these arrows are going to be a huge help. The arrows are showing us how much is below here. So you're right, Blake. Blake got it right there. 2.5 is below here, and the lower percentile is on the lower side. So if this is the 2.5th percentile, what is going to be this number over here? If that is the 2.5th percentile and we have symmetry, great job, Christian, right there. Yep. So due to the symmetry, if that's the 2.5th percentile, then what is the top number going to be? If that is the 2.5th, what is the top number going to be due to the symmetry of the curve? Due to the symmetry of the curve, if 2.5% is below here and 2.5% is above here, close Santi, close Christian, not quite. So 2.5% is going to be above here. So 2.5% is above there. Is that making sense? And always write the numbers down. See if it makes sense. It's going to be the same thing where 2.5% is above here. And it's going to be 97.5 is the 97.5th percentile. Does that make so? What is the percentile on the curve right here? It is the top, or it's the 97.5th percentile, the top 2.5%. Does that make sense, Evan? How are we doing on this right here? Finding these numbers, understanding that if 2.5 is above here and 2.5 is below here, then that is the thing right there. What does that say? Huh. Wow. Man, that's rude. Oh no, my sister. I'll text her later. Gotta remember. I'll rephrase it. Yes, Santi, that is correct right there. That is correct, Santi, right there. Santi said 100 minus 2.5 correct because 100% of the curve is everything. And then we could subtract this off right here. And that is the 97.5th percentile. Great job, Santi, right there. How are people doing with all these numbers and writing them down here with practice? How are these numbers doing? Does it make sense while we've written all these down? I think people see it. Because the last thing, feeling good, nice job, Christian, right there. The last thing would be the percentiles here and here. Now, if 99.7% is between these numbers, what is outside total? What is outside total? What is outside total? If 99.7 is between, then what is outside total? If 99.7% is between, .3 and 0.15 on either side, right? So you know it's nice and easy? What is the bottom highlighted number going to be? What is the bottom highlighted number going to be? What is the bottom? The bottom number means we're at the what percentile? The bottom number means we're at the what percentile here? The 0.15 percentile exactly. And then use your trick for the other side. I think Santi knows it really well now. The percentile on the other side of the curve would be what? So the percentile over here now is going to be the what percentile? Yeah, Santi, we'll do some practice questions now that we've drawn this out. Good practice. The top side of the curve will be the what percentile now, because percentile means area below that point. Be the, not top 1.5, careful, careful. It's the top what percentile. Not 1.5. People are saying 1.5, not 1.5. We don't have it yet. Santi did it earlier. Santi did 100 minus that. So remember earlier, Santi, oh my gosh. Oh gosh, deleted the whole curve right there. Not 98.5, close to the answer. Not 98.5. It's going to be, and that's why we like doing this out and practicing right here. This right here is the, so I'm going to say a great job, Evan, right there. It's the 99.85th, because take a look, above here is that little sliver of the curve. Does that make sense to see that right there? That these numbers right here have to add up to what? Those numbers right there have to add up to what? So those numbers on the curve have to add up to 100. And if you follow along the curve right here, and you go and start adding up your percentages, what do the highlighted numbers I've highlighted add up to right now? The highlighted numbers on the curve add up to what? What would these... No worries, Blake. Everyone does that. That's a very common error, Blake. We got to throw you some points for that. What do those highlighted numbers on the curve add up to right now? What do those highlighted numbers on the curve add up to right now? Those highlighted numbers on the curve that I've highlighted, 0.15, 2.35, 13.5, add up to what? What do they add up to? If you add up all the way to those numbers right there, what do they add up to? They add up to 16. Now, if you were to add to it 34, what does it add up to? If you add up to 34, what does it add up to? If you go to 34, it adds up to what? So add 34 to 16, you get what? If you add 34 to 16, you get what? Great job, Tess, right there. If you add 34 to 16, you get what? You get 50. Then I'm going to ask you to add another 34 to it. And if you add another 34 to it, you get 84. And if you add another 13.5 to that, you get 97.5. If you add another 2.35 to that, you get 98.5. And if you add up this, you get 100% of the curve. Is that making more sense right here? Is this the curve the same for every data set? These are the same, and we put the what's below it. So, Christian, you're right. This is the same for all data that's normally distributed. And so I've put the what's below it right here. I've put the what's below it right here. I've put the what's below it right here. What have I put below it? And then we're going to write a test question here to help out. I've put the what's below it since it's the same for all normally distributed data. For all normally distributed data. Kind of the context, but the z-scores. Yep, and then we'll do some practice problems right here, Santi. Really good question. So now let's do practice problem with z-scores. So that took us 13 minutes or 12 minutes to write out the curve. And we took a lot of time. I can draw it out a lot quicker as I memorized it. Stat Tool 1, Chapter 5, practice problem. So now we're going to do a practice problem. Those are the z-scores below. And check this out. You ready? So if you knew this information, I wanted to move it down. Darn it. Okay, so we'll leave this open over here as one of our tabs. And let's say this problem. Test scores are normally distributed with a mean of 80 and a standard deviation of 8. You scored in the 97.5th percentile within 1 point. What was your score on the test? Oh, but yeah, I'll leave it. Hey, Chase, good to see you here. Does anyone know the answer to this? You say, wait, the applet. And I say, well, it's using empirical rule numbers. Would you be happy if you scored in the 97.5th percentile? That's the first thing to understand about this question that I've written. Would you be happy if you scored in the 97.5th percentile? Would you be happy? I'd start doing a drawing right here and think, would I be happy? I'd be happy. That means I'm at the top of the class, right? Only 2.5% of students scored higher than me. So only 2.5 scored higher than me. 97.5 scored lower than me. So are there some numbers that are jumping out in your head right now? And Evan, watch this, Evan. Evan just said it's like a 96. That's what we would put on our test, right? If we had here a 96, Evan's saying it's like a 96. Well, Evan, watch this. We don't have the applet on the test for some questions. But if you went right here and said you are at the 97.5th percentile and the test had a mean of 80 and a standard deviation of 8, it's like a 96. Evan just solved it like that. So, Evan, how in the world did you get that? How in the world did you know that? Writing the... Oh, you're writing the... Nice job right there. Shout outs to everyone on the T right there having some fun. So riding the T, good times. So when you're looking at this right here, a z-score of 2, right? Because on the curve, we have right here that the 97.5th percentile is at a z-score of 2. So if you know the z-score is 2, you multiply the standard deviation by 8. It's going to be a lot easier if we take the same problem we just did and put the context below here. So what I'm about to draw you is the context, which would be 80 at the center, 88, and 96. So this is what Evan, why 8? Good question. Why are we doing 8 right here? Because 8 is the what? So when we draw this out, 8 is the what? Here's 80, and here's 88, here's 96, and so here's the 8 right here, and so that's 8 units, and there's the mean. And does that make sense? Because standard deviation is 8. Great job there, Chase. Does this make sense right here, how we're able to find the 97.5th percentile and things like that? Now, we could change up the question to make it more difficult and use one where we don't have the David M. Lane. And so let's try another version of this. So similar question. Test scores are normally distributed. with a mean of 80 and a standard deviation of 10. You score in the 90th percentile. Your teacher reports to you that the z-score of the 10th percentile is negative 1.282. What is your score on the test? Okay. Is not the move. Oh, so sorry, Evan, right there. So now this is a tougher question right here. I've upped the difficulty a little bit. Test scores are normally distributed. So what's the first thing you'd want to do if you get a question like this? Test scores are normally distributed with a mean of 8 and a standard deviation of 10. What's the first thing you would do right here? What would you do with a question like this? What's the first thing you're going to do? Draw it out, Jackson. You know what's up right there. What is... No. We're going to draw it out right here. And so we draw the normal curve. We get a nice drawing. Ooh. Now remember, you're at the 90th percentile. So what do you instantaneously know about your grade right here? So if you're at the 90th percentile, you are at the 90th percentile. You are what? Chase, that might be the right answer. But be careful, you're at the 90th percentile. That means you are what? So I think people might have the other answer. You're at the 90th, so you are where? You are at the 90th. Where are you on the curve? You are at the 90th. Great job, Evan, already solving some of the problem. That is correct, Evan. And we know we are where to the mean. If we're at the 90th percentile, we have to be where? So we're just drawing the curve right now. We're putting the z-scores below it. And so these are the z-scores. Then we're going to draw the context numbers. Really good exam grades right there. So it gives us the z-score right here. And so this is the z-score for the 10th percentile, meaning 10% of the area is below. So that's where the 10th percentile is at. So now we know where the 10th percentile is at. So the 90th percentile would be where? Is the first thing to solve. The 90th percentile. Great job, Chase, right there showing it. Great job, Chase. We won't use the data M lane for this, or it could show pictures. You never know. It could show pictures where we gather this information. So the 90th percentile, and I think Chase is showing it, has a z-score of 1.28. Does that make sense to say that if this is the 10th percentile there on the low side, the 90th percentile would be right here, and this right now is the middle 80%. All this was gathered from hearing the 10th percentile is here. There's the 90th percentile. So I just want you to tell me whatever you answer needs to be between what and what. Whatever the answer is needs to be between what and what. Whatever the answer is needs to be between what and what. Whatever the answer is needs to be between what and what. If you're at the 90th percentile, which means 90% of grades are below you, it needs to be between 90 and 100. Great job, Muskin, right there. And if you look back at our drawing, look right here. The 90th percentile from this drawing we did earlier all by ourselves is somewhere inside of here. The 90th percentile is around there between 1 and 2 standard deviations at all times. So we have here the same drawing, and we're just trying to figure out where this is at. So it has to be a number between 90 and 100. We know the z-score for it, so let's take the z-score. And to solve it, we say that the observation is equal to the mean plus the z-score times the standard deviation, because a z-score literally tells you how many standard deviations something is above or below the mean. So the mean being 80 right there, that's the center of the curve, plus the z-score of 1.282, which was found because we knew it's the positive z-score, not the negative version, and then we times it by the standard deviation of 10 to get a value of 92. And that's 91.28. And if we use the David M. Lane to confirm the answer, just for practice and to know what it would look like, we would say right here the 90th percentile. We just got to change the standard deviation. And there it is, 92.8. Did I not carry the decimals right? Oh, wait, 90. Oh, my gosh. Brian can't math. 92.8 right there. Double check your math at all points. That's why we check our work. And we get 1.28 times 10 plus 90. And there, 1.28 times 10 plus 80, 92.8. And we do another one like this. One more z-score problem, please. You're welcome, Chris. Yeah, let's do it here. Does that make sense how I solved this? And this was not using the applet at all. It just gave you this information. If you have applet pictures, let's do one with an applet picture. But once again, always try to draw these things out. So I'm going to do one with an applet picture to make up a fake applet picture. So let's go right here and say, sure. So this right here is an applet picture with the same information. And let's say test scores are normally distributed. Test scores are normally distributed with a mean of 80 and standard deviation of 10. Did I do 10 down here? I did. What percent of students are expected to score below? Really? I hate it does that lately. A 96.45. Okay. What percent of students are expected to score below a 96.45? So see if you can solve this right here. If you know how to read the applet, I don't think it's that bad of a question, but what do people think? Take a moment, try to solve the question, and then I will explain the answer to it. Test scores are normally distributed with a mean of 80 and a standard deviation of 10. What percent of students are expected to score below a 96.45? So what is the graphic showing you? Let's see what people say. A little chill music right here while we do this. That's too not chill. So you want to start labeling the information it gives you. We'll let someone get the answer and then we'll explain it. That is the z-score. So the z-score is that. Good answer there. Backworking the z-score. The z-score, which we don't need right now, but it's good work, is 1.645. That is the z-score. Oh, no worries, Evan. This says 90% is in the middle. Great job, Blake. Yes, Blake, 1,000 points. That is correct, Blake. Yep. So if you get a graphic like this, the first thing you want to do is start labeling it. Since we know 90% is in the center right here, we would label this 90% immediately. That means right here, this is going to be 5% above and 5% below. So now when we figure out what the area is below it, we'd want to go right here. Does that make sense right there? Who follows along right here that we're talking about? We know the middle 90%, and then we want the area below that line. Does that make sense? Then you have the 96 is between 90 and 100 z-score. Well, you can break down the areas in a lot of different ways. The important thing is to know that we're talking about below that line right there, that red line, the percent of area below it. And you would just add up these two numbers right here that you find by the middle 90%. But that would be it right there. Good solve on it. And so this is one where we might give you an applet picture, and then you'd have to know how to use the applet picture to find it. And there's a lot of things you can find out right here. How are we doing on this? We could do like another one here, but what do people want to do? What questions do you want to cover? Your call, the questions you want to cover and talk about. Let me know. Got time for like one more. Good work, everyone. Evan. Cracking me up, Evan. You're cracking me up. Can you explain a z-score? Yeah. A z-score tells us how many standard deviations something is above or below the mean. So if I told you that Like, just interpret this for me. Your test score is a z-score of 3. What does that mean if I tell you that? Oh, we'll show that again real quick, Santi. Just explaining what a z-score is right here. What am I telling you if I say your test score is a z-score of 3? Your test score is a z-score of 3. Hey, Noah, good to see you here. Let's drop some points. Yeah, Noah, let's throw 2,000 points. Noah, thank you so much. Thank you for being on, dropping things on the Discord. Noah, just love seeing you here. You're just so happy to see you. How the test sign up works. If you have to take it early, make sure to sign up on the forum. Make sure to sign up on the forum. Well, that would mean you're at the 99.85th percentile. That would mean that. But if I say your z-score is 3, I'm telling you you are what to the mean. If I say your z-score is 3, I'm telling you your score is what to the mean. Like, what does 3 mean? Like, if I say your z-score is 3, what does that mean? Everyone throwing all that positivity towards Noah. Away, kind of, and above, yes. So remember, z-scores can be positive or negative. If we said your z-score is -3, that means your 3 standard deviations below the mean. If we say your z-score is 3, that means your 3 standard deviations above the mean. So if I said the test had a mean of 80 and a standard deviation of, let's say, 5, what would be your score on the test? So you should be able to be like, oh, my score on the test was this, if you understand what a z-score is. Like, knowing what the z-score is, you can easily compute this and be like, well, I'm 3 standard deviations above the mean, so my score was this. Not 130, close, not 130. Your score would be what? Like, knowing that it means you're 3 standard deviations above the mean, 95. Does that make sense, Santi? Oh, yeah. So this right here would be, I changed the numbers, yeah, because I'm changing the numbers here and there. Great job right there, Santi. You're 3 standard deviations above the mean. So you would go here, and you go to the mean of 80, and you go 80 plus 5, 5, 5, 3 standard deviations, and that means you're at an 85. So you go 3 standard deviations above the mean. Oh, no worries, Santi. Santi, we got to throw you 1,000 points too. Keep asking those questions. We practice here as much as we can, and I just love it when people are asking questions. Office hours where there's no questions are still like, bleh. So what we could do is we could take, and I think this is what they did, is how could we find the z-score for this number? Why does it keep doing that? You're so weird, computer. There we go. How could we find the z-score for this number right here? How could we find the z-score for that number? The z-score formula is, I know, well, I think because you don't have to show people your points, so it's kind of like, if you want, you can use different names. So I can see the point leaderboards. I know who's at the top. I can tell you if you're at the top. And then you can tell me how to find that z-score. I'm at the top. Blake, you're second. Blake, you're second to the top right there. I can show it to you if you want. You're second. Blake, you're leading by like 100,000. You're destroying it, Blake. Yeah, because I'm here at all times. I can track how many points total are given out. You're second, Blake. Great job. I better be third. Evan, you are 1, 2, 3, 4, 5, 6, 7, 8. Evan, you're 8th. If you have 2 accounts, Evan, let me know. I might need to merge those accounts. Let me see. Evan, you do have 2 accounts, but the other one only has 19,000 points on it. So, yeah, you only have 1 hour and 19,000 points. I know, right? I got to compete. We're all here to having some fun. I love it. I love that people. I like what have you? Is this 35 hours going strong? Just watch out my points. See, I've already got the 500,000. But great job right there. So to find the z-score, I'll say how to find the z-score, and then we're ending off starts here soon. To find the z-score, it's observation minus mean over standard deviation. Observation minus mean over standard deviation. That's how we find the z-score. So we take the observation of 96.45, subtract the mean of 80, divide by the standard deviation of 10. Does that make sense, Santi, right there? Sorry, Blake. Well, I'm here at all times. I get all the points. If I'm live, Mubot is live. So, or if Mubot's live, I'm live. So, observation minus mean over standard deviation, which got the 1.645. Just rounding it right there. So that will get you that z-score up there. So just knowing how to find information like that and understand it, and also seeing it here visually that it should be around there. No, but really great work, everybody. And what are people's thoughts? Like, I want to do more gamification of the class. I actually have thought about making an alternative site where, like, you have a character and you can, like, equip them to learn or something. Like, like actual like character creation, yeah, it would give you numbers like this on the test. Like this is exactly how a test question could look. There's some people up there. All this information right here could be questions asked. We don't usually ask like what is the z-score. We could, but everything right here we obtained from, if you look at the limited information we were given for this problem and then what we were able to solve for from it, like you can be given an applet picture and then I think someone's cheating. No, I swear it's a very close running between the tops. With you and the other students, ninth is just 100 points behind you, and then third is about 10,000 points ahead of you. It's a very close running between everybody right there. It's the people at 250,000 are all really close together. And so I'm trying to make it so probably by the end of test 2, some people are hitting the 500,000. So I'm adjusting the points. I got to head out another class. Santi, great work. TA privilege. I wish I could have got for the thousands of hours of video recordings that I've watched. Oh, I'm sorry, Evan. Thank you for watching. I wish we could record those somehow. What student has the most points of all time? Well, I do have hours. And so once again, I can't, but I do have hours. There are students who have, and not cheated, with almost 200 hours of watching or being here live. There's 2 students. There's one student at 197. There's another student at 194. A student with 133. I've never deleted the hours, but the students with the top hours, how do you get that? You're just here for hours. It's so cool because I see all these names and I remember all them. Like, it's just going back over the years, like seeing the names of the students. Like one of the students actually just dropped. 2 of the students dropped by today to say hi. 2 of the students with the top hours dropped by to say hi today. But it's just so cool seeing that. Yeah, man, just seeing the names of the people, like who's dropped by to say hi. It's so cool seeing all the names. Yeah, I know, right? It's pretty good. Thank you, Evan, Blake for being here, and Evan. Noah, you're, well, I think I can say it. Noah, you're on that leaderboard. Yeah, Noah dropping the Discord right there. We're always trying to help people out. So I'm even thinking of, let me ask this really quick and then we'll end here. Like, so with my new job as technology enhanced, well, we're dropping the survey. I don't think we've dropped the survey yet. Let me see if it's gone out. Let me see if a bunch of people have already responded to our survey. That'll let me know. Like, hopefully, web surveys. Like, did we get it? Okay, let me look. Okay, logging into Qualtrics. Ten responses, so it hasn't gone out yet. So one thing I'm trying to do is set up a group of students to be the sounding board to kind of reach out. We're not going to decide everything by like what the group of students decides. Like, I don't want me to be the one who decides everything. I don't want just a small group of students to decide everything. We really need to be cohesive because I've got some really big ideas. And one thing I've thought with our Stat Nation Discord, Noah, is that we need to talk about rebranding it, but call it like Haslam Nation or Haslam Discord or something like that, and make it so it's a Discord for any class in Haslam. Now, before I do that big of a reach, I need to make sure like this would be a lot of stuff. Like there's a lot of people to talk to before we go. I can't go that big without sort of like, but here's what I would want is that any class you have in Haslam, we could set up a class for that and you could communicate with those students, and then you would also be able to communicate across your whole Haslam career. I know, right? Is there a Haslam group me? Is there a Haslam group me? I think that's the only way to compete. You might be, Jackson. Is there a Haslam group me, Evan? No? So here's the thing. When you're a freshman at UT, I'd love it if we said, hey, there's a Haslam group me. Any class you have in, I mean, not a Haslam group me, a Haslam Discord, any class you have in Haslam. The group me couldn't hold 40,000 students. Well, the Discord can. So, well, we don't have 40,000 though. We have like 4,000? I don't know. There's a UT group me. So, exactly. And then you can tag people with 10,000 members. Wow, there's a group with 10,000. Crazy. So, I mean, put that link in the chat. Which link? They're dropping the group me link, are they? So what I'd want is, and I'd need to talk to the educators, but saying that we are going to set up a Discord room for every class, because right now GroupMe's exist. Like, and obviously you can have GroupMe's and stuff, but if we set it up that you could have a Discord between all your classes, and that way you had a social network for every one of your classes, what would people think of that? Like, if there literally was a room for every class, like you could go and it already existed before the semester started. Like, just knowing that you go to the Discord and there's a room for every class. You don't have to say, where's the GroupMe, where's the whatever. It's just like, boom, there's the social group for that class. And you could just log on and be in that social group for that class. Just like that. They'd all exist. And the thing is I'd want to promote it such that, like, hey, if you want to link up with your students, would people use it if it was proctored? So that's the thing too, is teachers can obviously see it. I think that's good. That I know, that's the thing, is like, as long as you're not doing anything crazy, we don't care. I know, Evan, that's the issue. And that's part of the issue right there, is that really trying to cut down on that. Yeah, exactly, Blake. I think this would be very helpful. And I need to talk to some people higher up and be like, look, I think Haslam needs to make it like we have an official. I'm getting oh, it's the shirt. It's the shirt. It's all got a tint of green in it. It's only this shirt. I'm not going to change my thing. This is off topic, but the exam consists of multiple choice, true, false, free response. No free response on this response, not on this exam. Similar to the practice exams, but it looks like our chem is confident. That is very correct. I have like 40,000 group me's. So now you could just, have one Discord thing, and then you could join the classes, and we need to make a, so that way, and a bajillion notifications. So that way you'd only get tagged for stuff for your class. So that way you would only have, like, you'd be in the Haslam Discord, and then in the Haslam Discord, you could see it. These are things I haven't floated to the higher ups yet, but it's one of the big things where I'm like, if we create our own Discord for everything in Haslam, and then we say, look, like, if you want to join up, there's already a class for you. There's already the tool one, there's already the accounting this, the, management this, and then group me's in my experience have been useful for maybe like a semester and is total toss up in terms of getting actual help. Yeah. I know, but that's the thing, is I am, and I'm the faculty director for technology. So it's stressing you out. And so, yeah, so that's, how is it going? Is it Alyssa's group me? Is it going pretty good? Is it pretty good right there? Like, is it, we want Alyssa's such a pro, and she's doing her review tonight. But I always want to hear from the students. I want to hear your responses and move forward with what you think. But what would people's thoughts on that be if Haslam had an official Discord, and then every class in Haslam, which we'd need to set up, every class in Haslam had its own channel. So you could just be signed up to the channels for the classes you're in. And then at the start of the semester, you could be like, oh, I can just join my social channels for my classes. Difference is that you're always willing to be helpful. Oh, you're welcome. Yeah, and then, I mean, it really would depend on the teachers, like how good your channel is. Yeah. And then you could have current students, former students, people helping out, people wanting to join in, people saying, hey, I'll tutor. So we would, be like, this is for students. We have the security lockdown. And then, of course, we'd want to report any misconduct. Because my biggest fear, there's 30 clubs that use me in Haslam as well. So we could even tell the clubs we would make a Discord for them if they wanted. But the thing that I think about this is people are going to make group me's, which is totally fine. But I want something with you that stays. I want something you have throughout multiple classes. Someone noticed what I'd like the idea for other students. Awesome. Yeah. Awesome with neuroscience, Ivana, right there. Yeah. So if you're in Haslam, I'd love it if we said, here's the Haslam Discord. People who love Discord like me use it all the time and would love it. The ones that think I hear new Discords, they ever confused on how to use it. Yeah. That's you get used to it, right, Chase? You're like, oh, it's just like it's got different channels and stuff. But I've heard a lot of people say it just stresses them out seeing everything in Discord. Brian, what do I do if I get 5K points right now? I'll give you 1,000 points, Evan. Let's give 2,000 right here. I really appreciate the conversations. Chase, what do you think, Chase? Do you think it would work if we said to students at the start when they join Haslam, like when their first semester, we said, like, here's the Haslam Discord. Do you think that would work? Do you think it would work, or do you think it would just be... Because what I want to do is I want to steal the group me market share. I want to be like, the Discord's the place to go. and you have classes all across. I've heard some instructors are resistant to platforms like Discord for some reason. They have no idea what it really is, so they're wary of implementing it. Yeah, well, people are going to use GroupMe's anyways. That's going to be my argument when I bring this to the higher ups. I'll be like, GroupMe's exist anyways, so let's just make our own official version. I still have no idea how to use it. Yeah, so we probably need some Discord instructional sessions or something. So we need good responses there, Evan, because like a lot of people just don't know how to use it. So showing people how to use it, like maybe doing some in-person stuff, like saying like, oh, this is how you use Discord. You just click this and you do this. We've got some instructional videos, and literally Mubot's dropping the Discord right now, which I think that link still works. Let me see if the link works. It does work. It brings us right to it. And we got people in the chat talking right now. We got members joining. A few people just joined today. Someone just joined 8 minutes ago. Thank you to the person who joined 8 minutes ago. And then you have to add the role. So you have to make sure to add the role to yourself after you join. So I think that can confuse people too. Is like, wait, there's roles, there's this, there's that. Thank you, Noah, right there. So yeah, and that, as Chase said right there, once you understand how to use Discord, there's so much more capabilities. And it's just really awesome. And to think that we can have something that stays with students throughout all of Haslam, and then maybe we could talk to other colleges and say like, hey, look, because I think all of UT would be too much. Like, it would be too much. And then also, like, I mean, we haven't had any real problems. We've had to ban a few people because I think they got hacked. Which, be careful clicking links on Discord. It's like GroupMe. You know, you see a random link on a GroupMe, you got to be careful because there's bots and stuff on GroupMe, right? Discord partner with deal with UT. I mean, maybe if they'd let us. I'd love it if we were like the largest university. We're I think we are the largest except for Minecraft, the largest on the social UT. But if Discord heard like, hey, we might become the largest group at a university, they might say something because that's what they probably want. So I should talk to Discord, might reach out to them and say, hey, look, I'm thinking of implementing this idea. You know, we want to make it the best. Now I need to talk to the Haslam higher ups. So anyways, I wanted $100,000 on GroupMe. No, Blake. No, Blake. Blake, no. Mark Willoughby, yes. Willoughby. I was pronounce Willoughby's name. Yeah, Mark is such a great guy. Huge shouts to Mark, who's student engagement with Haslam. Yeah, Blake. Yeah, he is higher ups. Yes, he is such a great advocate for students. Like, the things he does for students is just absolutely amazing. He is like connected to the students, like always been caring for them for over a decade. So huge shout outs to Mark right there. Huge fan of Mark. Mark Willoughby right there. Just excellent guy and just one of the top people we have in Haslam, like in terms of what he's doing for students, how he helps people out, and just he's been here a long time. So huge fan of him. And he did a lot of help when I was at UT. He helped us set up the Mario Kart event. And just huge shout outs. I got to see some pictures of that. We got some jokes in the chat. So we're definitely going to come up with some ideas, and it's going to be student driven. So with that, it's time to go, everybody. I'll be working on these ideas. The survey's coming out. If you see Mario Kart, we did Mario Kart at the start of the semester. We did in the Student Engagement Center, which Mark Willoughby runs right there. Explains we had a Mario Kart tournament. Sorry to keep asking questions, but when we use Partorio, we can show our ID and sheets of paper using. Yep. Do that right there. Show your ID, show your sheets of paper. I'm sorry, Evan. We'll probably do it start next semester again. We'll try to do it like bigger and bigger each time. Evan will do it. We had someone came down who was insane. I mean, I fancy myself good at Mario Kart. You probably can. As long as it's you. As long as it's you, Blake. If it registers, is good. So we just want to make sure it's you. That's all we care about. I'm going to ask you an important question tomorrow, Brian. Don't let me forget. I'll try not to. You could ask me now if you want to. You could email the question too. Or Discord the question. I'll help you. Yeah, well, it was really cool. We had this guy come down. We had probably like 30, 40 people come down, I think, because we gave away rubber duckies too, and they let us give away the Pop-Tarts they had. I'll ask him now. You'll ask him now? You'll ask who? What are we allowed to have for the exam? You're allowed to have your calculator, your sheet of paper, and writing utensils, stuff like that. Knowledge. Have all the knowledge. Yeah, bring a bunch of knowledge. Great job. This just I think, yeah, we prefer a sheet of scratch paper. That way you don't have to be like showing 20 sheets of scratch paper, because it's like like one sheet, two sheet. One sheet should be good. There's just a few like the normal probability stuff, the the normal distribution, I would say. I'll show 30 sheets. Just make sure to show to everything, yeah. But no, we'll probably do a Mario Kart event. They allowed us to do that. Nothing like playing Mario Kart in Haslam. Maybe an end of semester. You know what would be cool if we did it at the end of the semester too, like a study day thing or something. Like just come down and play Mario Kart. Like just relax. You know, like just chill. Because I mean, in truth, I just try to put things in perspective. Like I can't tell you how many exams I've failed in life. How many times I've failed. It's not about failing, it's about trying again. So if the exam doesn't go well, you get a second shot, you get an exam 2. If the exam 2 doesn't go well, you get an exam 3. If you fail stats, you get to do it again. But that's not what we like to do. But we do sometimes fail in life at our goals. Aw, Blake, no worries. You can always swing back by. Look at, we have Noah come by today. We had Charlie come by today. You can be someone who swings back by and says, hey. Like, and then I'll be like, hey, Blake. Like Charlie, it just seems like yesterday he was taking my classes and now he's in upper level classes. Noah just recently-ish. I mean, Charlie and Noah, yeah. Evan, no worries. No worries. If you fail something, we just get up. Let me tell you this much. You fail something, show your face again. Don't worry. You just be like, but if you lose at Mario Kart, that's when you can't show your face. I played him, didn't I? I played and I came in second, I think. The guy who came down and played Mario Kart was insane. He was cutting the track. He said what he did was he worked at a place that did Mario Kart tournaments, and he'd compete in the Mario Kart tournaments. And he knew all the shortcuts on the track, so he was really good. And then on our Mario Kart, we didn't have everything unlocked, and they were like, you don't have everything unlocked. And I was like, well, we beat it on Wii U, and now we have it on Switch. I haven't played since I was little. Well, break out the Mario Kart. So with that, everybody, it's the end of class or the end of office hours. Thank you so much. Great office hours, everyone. Good relaxing time. Till tomorrow or Wednesday. I'll see you soon. Bye for now, everyone. Bye.